More seconds. I started the stream, but then I stopped it because I have not done my mic. I need to have the mic on. Okay, I think we're good to start. Welcome everyone. I'm coming to you from my house now. I will, there you go. I'm coming to you from my house. Thank you for joining us. If you're here live, if you're watching the recording, no worries at all. And for those of you who are in Canberra, sorry about the lockdown. Lockdowns really suck, don't they? And I hope not too many of you are really this inconvenience. I know a lot of you are living in halls, and if you're living in halls, then I know you're in a particularly nasty spot at the moment. So just don't hesitate to reach out to me via a private message if you've got if you're finding things difficult or you're having a particular situation. So please just don't hesitate to reach out to me, and I'll do whatever I can. But in the meantime, and many of you are not in Canberra, and many of you are in places like Sydney or in China or in India, and you've endured COVID already, or maybe you're already in lockdown somewhere else. And for those of you who are elsewhere, my sympathy goes to you as well, because I know many of you have endured even worse than what Canberra has. We've been actually very, very lucky here in Canberra. So let's now move on to the lecture. I want to start off by going to some admin. First of all, assignment 1 is due before the Monday lecture at 2:45 p.m. As announced before. And of course, as I've said many times, if you the deadline's firm, but we've got strong special consideration processes in place at ANU. So if you think you were significantly disadvantaged, you should fill in one of the ANU's special consideration applications. Some of you are probably feeling stressed about the assignment. Regardless of COVID, you're probably feeling stressed about the assignment. Please don't let it stress you out. One of the reasons why I make it redeemable is because I don't want you to feel unduly stressed out. I want you to be able to say, okay, this is a bit too much. I'm going to step back from it. I can redeem it in the exam. All right. So if you're in that situation, please do that. Please don't either drive yourself crazy trying to get more done than you can, than you can afford to. Or, and please, whatever you do, don't get yourself in a situation where you think, I so badly need those marks, I'm going to do something terrible and commit academic misconduct, because that would be super bad. You don't want to go down that path. All right. So just a reminder, if you're really struggling, first of all, use Piazza. I'm trying to answer questions there, and you've got 16 amazing tutors who are also answering questions there, not to mention 450 other students, many of whom are giving fantastic answers on the forum. So don't hesitate to use Piazza. Although we won't be there at 4 o'clock in the morning the night before the deadline. Yeah, so so please try to use it during sensible times, and please respect the fact that we're not necessarily going to be available all weekend and all night. Okay, but we nonetheless are doing the best we possibly can to help you out with this, with all your work throughout the semester. Now, as announced, there's a lab test this coming week. Again, this is redeemable too. So if you're feeling stressed about it, please don't feel too stressed. You can just write it out and you get the marks back at the end. Having said that, the lab test, it shouldn't be hard to get a distinction level mark in the lab test. It will be fairly difficult to get a distinction level or high distinction level mark in the assignment, but not so for the lab test. The lab test, the reason why is simple. The lab test is really trying to assess that you've got up to speed with doing the basics in this course. And so the bulk of the questions, or all of the questions, I'm sorry, all of the questions there are ones that you've already seen. They're already ones from the homework. So what's going to happen is you're going to have very specific instructions for the lab. Don't worry, they'll be coming to you. And what you'll be told is to do a clone, not a fork, but a clone from your account in the exam GitLab server, which you can't access right now. The exam GitLab server will become available during your lab. You'll go to that exam server, and you'll find that there is a lab test repo sitting there waiting for you. All you need to do is clone that into IntelliJ, and do the test and push your results, commit and push your results as you go along, okay? It's not supposed to be an open test for fairly obvious reasons, because I'm already providing you with the questions. If it was an open test, it would be a bit of a farce. So how does this work? How can I have you guys doing this from your homes and it being a closed test, and yet I've provided you with the questions? Well, the answer is trust. I need to trust you all, okay? And I really hope I can. One of the mechanisms that we use in this course is what's called self-invigilation. And let me go there. Hopefully I've got the web page here. Yeah, here we go. So if we go here to the assessments page and we go down to final exam, you'll see here that there are instructions here on self-invigilation. Okay, you can go read that later. It's not onerous. You don't need to do it. But it's worth doing all this stuff, because the mechanisms we're going through right here, right now for this, are actually the same ones that we're using for the mid-semester exam and the final exam. So getting all this stuff worked out and worked through right now for the lab test in the coming week is a really good idea, because you'll get yourself familiar with all the technology and so forth, which shouldn't be too onerous. But during the lab test, you'll have tutors there to help you if you need to. And the basic principle is, oh, I've got a cat here, so excuse the meowing. This is what happens when you lecture from home. The basic principle is that we trust you, and what self-invigilation does is it says that you can, if you wish. If you don't want to, you don't need to, but you can, if you wish, record yourself doing the exam, and then if someone were to question what you did during the exam, you'd have evidence via that recording of what you did, and you could say, well, actually, look, here's how I did the exam. The reason why we do it this way rather than using something like Proctorio or one of these other technologies is that there's real problems with some of that technology, and many of us computer science academics have serious misgivings with things like Proctorio, and but you know, I guess there's a diversity of opinions on it. In any case, what self-invigilation does is allow you to provide evidence of your how you did the exam if you want. If you don't want to, you don't need to. Okay, it's 100% up to you. And so it's an opportunity, not an obligation. All right. Now with assignment 2. Oh, by the way, Leo is on the chat on Microsoft Teams, and he also has a speaker here, audio out on my laptop over here. So he will, just like we did in the physical lectures, he'll try and voice your questions. So if you have a question, put them into Teams. I'm not looking at Teams right now, but Leo is, and he'll voice your questions for me, and I'll hear him hopefully over Teams as he tries to answer those questions, as he reflects those questions back to me. So if you have any questions, put them in Teams. Leo will let me know. The next one is assignment 2. There's different assignment for COMP1110, 6710, and 1140. 2 different assignments. 1140, traditionally in this class, 1140 will build an AI to play a game. 1110, 6710 will write a solver to solve a puzzle game. The way we're doing it this year is slightly different to previous semesters if you've taken this course before, if you're lucky enough to have taken it before. What we're doing is on Monday, we're going to tell you the broad problem without giving you the tests and the detailed spec. And there's a reason for this. It's because we want you as a group to think about the broad problem before having your thinking constrained by the specific tests we're providing you, okay? The test will come a week later. So you'll do an upstream pull and you'll get your repo populated with all the normal material just like you had for assignment 1, okay? But for what you'll see on Monday will be a simple README, which will tell you everything you need to know about the game at the high level. It won't tell you all the encoding and stuff that we're going to use, and we deliberately don't want to do that at the start because we want you to think openly about the problem before being pushed down any particular path or implicitly pushed down some path. All right, any questions on that? Please yell. Now with that, we can move on. Now, J8 nested classes, and you're thinking, whoa, didn't you just do that on Monday? And the answer is yes, I did. I did do it on Monday, but I made a small mistake. Someone pointed out. I can't remember if they pointed out on Piazza or somewhere else, but there's a small mistake here. This is the code we were looking at, and we ran it. Let's just run this code. Where is it? Nesting, control, right. There it is. Okay, and everything seemed to work. The only problem was I actually wasn't testing it right. If you look here, I duplicated this code, but I didn't change this class. This was supposed to be showing 3 different ways of having those 2 different classes, the lecture theatre and the projector. One was with them as separate classes, one with them statically nested, and then one with them as an inner class. But I just duplicated that line there and pasted it down here without changing this to inner. So what we really wanted to do with this is this. So that was basically a typo on my part. Let's just run this now. And hopefully we'll get the exact same outcome. It's running right now. And there it is. Okay, it is, so it does work. Okay, so I told you before it worked, but actually I wasn't really testing it properly. This is a problem you all have to be careful of whenever you're testing, to make sure you're really testing the thing you think you're testing, because actually what I was testing was a static nested, which we'd already tested, simply because I'd forgotten to update that text. That's also another example of why you don't generally want to use cut and paste as far as possible. I do use it quite a lot in our lectures because I'm trying to do things as quickly as possible. So, and I often duplicate things because I'm showing you again and again and again the same concepts. Anyway, apologies for that error. Hopefully you can all see the result now. And what I'm going to do at this moment is I'm going to flip back to our next module. Where are we? Sorry, wrong thing. PowerPoint. There we are. Now, so we're now on to the next stage of inheritance. And folks, if you're feeling weary, and I'm sure those of you who are stuck in residential halls in hard lockdown are feeling really weary, but if you're feeling weary, know this, we're just about done with Java and object orientation, and we're moving on to the next plane of stuff. So this is one of the last modules. So hopefully you can feel a little bit of a sense of achievement that we're really moving on now. And I did promise you right at the start of the semester that the first few weeks were going to be a very fast start. Well, the throttle will be easing off now. We're moving more into higher level concepts and less about just learning lots and lots of syntax about how to write Java. Okay, so now on to 05, inheritance 2. This is the second stage of inheritance. If you were at the Monday lecture, or if you've watched it, you'll remember that in the Monday lecture, we looked at inheritance, and we gave this, I did this big long example in IntelliJ using animals, right? And we had a hierarchy. We had Java-lang object, of course, is the root of the hierarchy. Then we had animal, and we had reptile, fish, mammal, and so forth. And then ultimately, the leaves of that hierarchy, we had things like human, which is a kind of mammal. We had platypus, which is kind of monotone, and eastern brown snake, which is a kind of reptile, and so forth. Okay, so we had this notion of a family of types, a family of classes that inherited from each other through this rich thing, which reflected biological inheritance or genetics. Okay, very roughly. That was what we did before. Now we're going to go to the next part of that unit, and oops, I don't need to do that. So the first thing to do is to remind everyone that in Java, the most general kind of thing is a bit like, the equivalent in, I've said this lots of times in class, the equivalent of this notion of a thing in English just being a general way of saying something tangible. It's a thing. In Java, we have Java-lang object, which reflects that. But what's interesting is that Java-lang object has certain attributes. There's 2, 4, 6 methods, which I've listed on the slide here. We've got 6 methods which Java-lang object has. And what that means is, every object in Java always has these methods because everything inherits from Java-lang object. And I'll just quickly rattle them off. The first one is clone, which allows you to copy an object. Okay, so you can say some object, Mary is COMP1110 student, and you can say Mary.clone. Now you've got 2 Marys, okay? 2 Mary objects. We've got equals. Equals is an incredibly important one, and this is a topic we're going to come to again and again and again because it's a concept that is really fundamental, but it's people often see it as tricky, and that is the difference between equivalence, which is what equals gives us, and equality of a reference. So, and the difference is if I have 2 references to one object, 2 different references to one object, I can use the double equal sign in Java to say, is that reference the same as that reference? Are they pointing to the exact same object? So that's useful sometimes. But sometimes I'll have 2 objects, like for example, if I clone Mary, I'm going to have 2 Marys, right? And the name is Mary, the age is whatever it is, 21 or whatever it is. They're going to be the same, right? But they're actually different objects. And what equals does is it allows us to say, are these two things equivalent? They're definitely different objects, so they're not equal in the sense of double equal sign, but they're equivalent. Okay, and that's a very useful thing because I mean, you'll see it used again and again and again and again throughout this course. And that this distinction between the double equal sign, which we use to see if they're referring to the exact same object, versus equals, which says, are these two objects equivalent? Are they both called Mary? Do they both have age 21? And if they are, then we'll call them equivalent, okay? And what's interesting is we can override that. When we make our own class, we can have our own definition of equivalence. Sometimes we might want to do that. We have our own definition of equivalence. We define equivalence ourselves, so we can override that. Finalize. We're not going to discuss finalization here. In fact, it's something that's kind of been deprecated. It's a concept that says that when this object is no longer reachable, then the garbage collector will call the finalize method automatically, which we can use to clean up stuff that this thing might have done. For example, if you opened a file, then the finalize method could be used to close the file and stuff like that. I'm not going to discuss it any further than that in this class. It's actually a controversial idea. The idea of having finalize in a language is actually in itself a controversial idea. So I'm not going to spend any more time on it than that. Get class is a very simple method which all objects have because they inherit from Java Lang object, and that just returns the actual class of the object. Okay, and we actually use that in the coding exercise in the last lecture. Hash code is a really interesting method. What it does is it returns a hash code for that object. Now we're going to discuss hashes in a lot more detail later on in the semester, and they're a really interesting idea. So don't stress if you don't understand what a hash code is. You don't need to know at this point, but what you do need to know is that Java says that every object has a hash code method, and it has another thing. It says that if two things are equal, they must return the same hash code, which is interesting also. So if two objects are equal, they must have the same hash code. But we'll talk about that in more detail later because later on in this course, we're going to talk about hashing, which is an interesting idea. And hashing gets used in cryptography, security, and we use it in other things quite heavily later in the course. So we'll come back to that one. ToString, you've already seen ToString, and you've already seen what happens with the default ToString. It's not particularly pretty. I've done that kind of on purpose in some of our lectures where we just use the default ToString and it prints out a bunch of stuff. Which is not very pretty. And you've seen many times in the class that I've overridden the ToString method so that we get a string that is a better representation of the object. So for example, with the COMP1110 student, we made a string which said their name and their age, their university ID, and then what grade they got in COMP1110 or something like that. Okay, we can override these things and create our own versions. Now this is an important idea. Now remember that hierarchy that we did in the last lecture where we had object, and then we had animal, and then we had mammal and so forth. I mentioned that some of these things are on the leaves of that tree, if you want to think of it as a tree. Some of them are leaves, like for example a human. There's no subclass in the animal kingdom of a human. There's no subclass in the animal kingdom of a platypus, and so forth. Okay. This concept is an important concept in Java too, and it has this notion of a keyword final, which means that you can't make a subclass. And that's useful because, well, it's useful for two reasons. One is it says that the person who wrote this code thinks that this concept is a final one, which tells you something about what they're thinking. So when I say human is final, then that tells you that I think that the type of human can't be subclassed for some reason. Okay? So that's useful information from a design point of view. It's also useful from a performance point of view. If Java knows that there can't be any subclasses of a particular class, it can do some interesting things with performance, which we're not going to discuss in COMP1110, but I'm happy to chat about it any other time if you want. And the final keyword can be applied to a class, saying human can't be overridden, but it can also be applied to a particular method, right? So you can have a method in mammal that is final, and then that means that any subclass of mammal can't override the method that was already declared in mammal. Okay, so you can't override it in a subclass. So for example, if Java Lang object had final on the ToString, we wouldn't be able to override ToString. But of course it doesn't have final, and we are able to override ToString. And there are reasons sometimes why you might want to do that. You might want to say, no, all mammals have this particular property, this particular behavior associated with this method, and we don't want people who are subclassing mammal to go and change it for some reason. Okay? Abstract classes and methods. I'm just going to check. I haven't heard a peep from Leo, so I'm just assuming for the minute that Leo, can you give me a yell? Can you hear me? I just want to make sure. I feel like I'm blasting away here.
Yes.
Oh, great. Leo can hear me. That's awesome. All right. So don't forget, folks, if you have any questions, don't forget to ask Leo and he'll voice them to me. Now, the converse of final was at the leaves and says no one can subclass it, is abstract. And abstract says someone must subclass it, okay? In the sense that this class doesn't make any sense as a concrete thing. For example, I can't make a mammal. I've got to make a cow or a human or whatever it is, a very specific thing, okay? Because mammal is an idea, not a concrete thing, whereas a cow is a concrete thing, a dog is a concrete thing, okay? Whereas a mammal is an idea, it's an abstraction. What in English we call it an abstraction, and that's why the keyword abstract is there, okay? So, and we can use that for a class, saying that this class is abstract, which we might do for mammal, for example, which means that no one can try to make a new mammal. They can only make a subclass of mammal that isn't abstract. Also, we can declare a method and say it is abstract, which means that a subclass must provide it. Okay, so for example, if we decide that all mammals must have a particular method, but it's going to be different for the specific mammals, then we can declare in mammal the method name and declare it abstract, and then that means that every subclass of mammal is forced to implement that. Otherwise, they're not a proper subclass, and you'll get red squiggly lines in IntelliJ. It won't work. Okay, so abstract is used to define concepts, that is entire classes as abstracts, and also behaviors like a particular method as abstract, saying someone who implements this thing as a subclass is going to have to implement this. All right, and with that, we've got time for the mini quiz. And in a moment, folks, I'm going to, where is our mini quiz? Here it is. Publish the poll. All right, terrific. What I'm going to do now is we're going to launch into code, and we're going to do something pretty easy and ever so slightly lazy to start with. We're going to go back to this. Remember this, I spent a bit of time building this whole thing up in the last lecture. We're going to copy the entire thing. I just did copy, and I'm going to do paste, and I'm going to rename it as, what's happened here? And we're up to 05, is that right? Yeah, there we are. So hopefully I did that right. Let's just see. IntelliJ is just being a little bit busy here. There it is. Okay. Do you want to add them to Git? Yep. Oh, they've got pasted into the wrong place. Okay, all right, no worries. I'll fix this, folks. Okay, so I've, what have I done here? All right, I've made a mess, folks, in case you haven't noticed. I've made a mess here. Let's just do that again. We'll undo that. I've made a complete mess. Yep. What I wanted to do was the following. I'll do it more in a more stepwise way. New package. 005 like that. Okay, there's our package, and then I'm just going to go in here and grab all of those classes, shift click, and copy them and put them into here, copy them to there. Okay, and hopefully we'll get them. IntelliJ is just locked up for a moment there. Hello IntelliJ, there it is. Okay, it's back, it's happy now. Okay, good, great. Okay, so all I did there was I just copied all the stuff we did on Monday. That's it. You all helped me with that, and I've just copied it here. What we're going to do now is we're just going to walk through these one by one, and maybe you can put it in the chat. What I want to do is look at each one of these classes except inheritance, which is the main one. We're going to go through each one of these one by one and decide whether it needs to be abstract, final, or neither. Okay? So think about whether it's going to be a final class. That means it's the leaf of a hierarchy. Abstract meaning it's not the leaf and something you can't make a concrete one of these things because it's an idea rather than a concrete thing. And then, so we're going to go through these things. So maybe you can put in the chat your suggestions for albatross, animal, and so forth, and just put them in the chat. Maybe Leo can yell out to me what you've done. And I'm going to start while I wait to hear. So I'm going to start things off by saying an albatross extends a bird. In our hierarchy, an albatross is a leaf. So, so we're going to declare it final. Okay, there it is. Final class albatross. Okay, so we've made albatross final. Animal. Oops, what's happened here? Why can't I click? There we go. Okay, animal. Is animal a concrete concept or it is an abstraction? It's an abstraction. It's a general idea for a whole family of creatures. So we don't want to create an animal. We want to create a specific animal. And the way we avoid that happening is going like this: abstract. There it is, abstract class. So we've made animal abstract. Now, if you're sharp-eyed, you'll notice that that little icon there in IntelliJ has changed. See that? We've got the little vertical bars for the abstract one and a little tiny tick mark at the top corner there for the final one. And you'll see that happen as we go along. Now, an arachnid is a class of creature. It's not a specific creature. It's an abstraction. It's an idea. And so we'll call that one abstract also. And Leo, just yell if you get anything there from the chat. And I will do it as you yell it out to me. So there we go. We've got arachnid is abstract because you can't create an arachnid. You've got to create a specific kind of spider and so forth. A bird, likewise. Bird is an abstraction. It's a general type of idea. It's not a concrete idea. Okay, we don't create a bird. We create an albatross, a seagull, a kookaburra. Okay, so we'll say public abstract class. Incidentally, some of you are thinking, well, I might want to do this, and you're absolutely right. There is a bit of a judgment call here, and it depends on what you're trying to do. So this is not all hard and fast, and it requires some interpretation of the context in which you're working. And I've made a fairly artificial one here with my slightly wacky animal hierarchy. And so, for example, here we come to dog. Now, dog, you might say that's final, right? Because you can't subclass dog. And someone else might say, hang on, what's a Dalmatian? Or what's a terrier? You know, what's a Labrador? You might say they're subclasses. So there is room here for interpretation as you look at these, and it will depend on the person who's designing the software making a call on what their intention was. But we'll call the dog final because we'll ignore all those other breeds of dogs and call them all, they're all canines. So we'll think of it that way. Same with the decent brown snake. We'll declare that to be final. A fish, on the other hand, is clearly what's happening here? I can't click on it. There we go. Fish is clearly a concept. There are lots of kinds of fish. So we'll just call the fish abstract. All right, my little laptop is struggling a bit here for some reason. A fruit bat, we'll call that one final. A great white shark is a kind. Oops! Wow. There's some delay here. Wow, IntelliJ is getting a little bit excited. All right, great white shark is. We'll call that one final. It's funny. My laptop seems happier in the lecture theatre than at my house. We'll call the human final, because it's a leaf on the tree. We'll skip over inheritance because that's the class we're using for testing. Mammal is definitely a concept. Okay, we're not going to create an instance of a mammal. We're going to create an instance of a specific mammal. Therefore, we'll declare this abstract. There it is. Just waiting for my IntelliJ to comply, and we get to monotreme. Again, monotreme is an idea. It's not a concrete thing. So we'll declare it abstract. And platypus is a concrete animal.
Oh, Steve.
Yeah.
Here's a very interesting question from a student.
Yep.
Can we both use final and abstract in the same method?
Can we use abstract and final in the same thing? We can't declare a class to be both. All right, a great question from whoever asked that question. Let's just try it. I mean, as you guys know, one thing that's always a good idea to do, and one thing I encourage you to do, is just experiment. Okay, we can't do this in this very simplistic way. It's quite possible the person. Okay, so if I want to make it final, then we have to make monotreme not abstract. You've got to have one or the other, and IntelliJ is telling us that quite clearly. In this case, of course, we actually wanted it to be abstract. But there's a more interesting question about what if we had a method in here. Let's just make one just for the sake of this question from the person online. Let's just say public void something. And then we'll do something here, like we'll do it. Sadly, my laptop is really struggling, so I keep mistyping. It keeps lagging my typing. That's why I'm waiting. There we go. All right, there it is. And we'll just, wait, sorry. My goodness. This is a bit frustrating. Okay, so oh boy. I would almost think about rebooting my laptop, but I actually rebooted it right before the lecture, so that's not going to help us. And some of you might even be able to hear the fan roaring on my laptop. Okay, anyway, there we are. So that's a method that I've put in the abstract class. At the moment, this method is neither abstract nor final, but we could make it final, which may have been the sort of thing the person online was thinking. Okay, let's do that. Now what we have is we've said monotrines cannot be created as instances because you've got to create the specific monotrine, okay? But every monotrine will have a something method, which prints out something, and they can't change it because we've declared it to be final. So this is an interesting mix of abstract and final. So I hope that answers the question online, and if it doesn't, maybe you can follow up with a follow-up question. Now let's go to platypus. Platypus extends monotrine, and it's concrete, okay? So we'll say final. Now what we can try and do here is we can try and implement something here. Public void something. Right? Now, imagine we're going to go and implement it, but IntelliJ says, no, you can't do that. And notice there's a little icon here saying that we're overriding. And so what does it say? It says, if we want to implement it in platypus, we'd have to go back to monotrine and make the one in monotrine not final, okay? Because as soon as we said the one in monotrine was final, it meant we couldn't override it down here, okay? So if we go back there and change the one in monotrine to not be final, get rid of that. That means every monotrine will have a something method, and the platypus, oops, boy, oh boy, this is annoying. It's going to print something else, maybe. Like that, okay? So the platypus will print something different, and we can make, and the platypus class is final. We could make this final too, but that makes no sense. Why does that not make any sense? Let's see what IntelliJ says. Does it care? It doesn't care. It ignores that, but it is silly to call that final because we've called the whole class final, so no one can override anyway, so it's kind of pointless. Okay, so now we've got two versions of something, depending on whether it's a platypus or some other monotrine, and if it's some other monotrine, it'll print out something, and if it's platypus, it'll print out something else. Okay, so that's a great question from online, and hopefully, oh man, my little computer is struggling here. Let's see if I can see what's happening. I can't see the source of it. I can't see anything being particularly badly behaved. All right, and then we've got a redback spider. We'll make that one final.
Here's a question from Benny. If you change the something method to abstract, can you still use it in platypus?
Absolutely. So if we go back to abstract in monotrine, if we say abstract, sorry, forgive me, this thing's so slow. If we say abstract, we can't make an implementation of it. So it's just got to be like this. Like that. Okay, so now we've made it abstract, which means there's no implementation of something, which means that not only can we put it in platypus, but we must put it in platypus. So if we comment this out, like that, I've just cut it out. Now it's complaining, saying, hey, you haven't implemented something, and you've got to implement something. There we go, implement the methods, and it's going to put in the something method. Okay, and we can put in, okay, so as soon as we declare something as abstract, it means every subclass must implement it if it's final. Okay, every final subclass must implement it. Okay, redback spider, we're nearly done here, folks. And reptile is abstract also. And finally, venomous, that's an interface, so this concept doesn't apply. And we go back to inheritance, and let me go back to where I was here. I had some notes here I was going to follow, maybe. Oh, that's right. I was going to demonstrate this idea. Right, what's happened to the fruit bat? Cannot resolve the symbol fruit bat. Why not? Oh, how strange. Oh, that's because I had a typo. There we go. All right, let's go back to inheritance. That's courtesy of my keyboard behaving badly. All right, there we are. We're here. Now let's try and do something like this and see if we can create an animal. We say animal, Sue equals new animal, right? Like that. And just put a semicolon here. IntelliJ is being a little bit smart here. It's trying to stop me from making a mistake. But I'm trying to make a mistake because I want to show you what happens. In fact, the animal's got a constructor, so we have to do that for sure. Let's just, oops. Right, so we've got to provide the age and the name. However, it says here, look what it says. Basically what it's saying is, to write this and make it work, we need to make animal not abstract. But actually, we do want it to be abstract because an animal is an abstract concept. So it's essentially telling us, no, you can't create an animal because animal is abstract. In fact, there it is. There's the error message. See that? Animal is abstract, cannot be instantiated. So what we can do is something like this. Okay? So we can declare Sue to be an abstract idea. Sue is an animal of some kind. And then we can make Sue a very specific animal. Here it is. Sue's a great white shark. Okay? I'll leave it back how it was and comment it out. So if someone looks at the lecture slides, at the lecture code later, they'll see the issue. All right, with that, we're ready to move on. Folks, I may go over time here. If I go over time, please just feel the drop off, watch the recording, whatever. I think it'd be good to finish this through. I know a lot of us are stressed and we want to get stuff behind us. I'm going to work through the lecture hopefully at a reasonably sensible pace and try and finish it off right now. And Leo may drop off at the end of the hour, and you're welcome to drop off, but I'm going to forge ahead regardless. All right, here we are. We're going to now talk about JavaFX, and we've got two parts, 1 and 2. As you probably all know or remember from the labs, JavaFX is the way Java allows us to do things with a graphical user interface. And here, it's designed for rich client applications. It has APIs. Oh, one very important thing is there used to be a thing called JavaFX, which is completely different. Okay, it's a scripting language. And so if you do a web search for JavaFX, be careful that you're actually getting the right thing. The old JavaFX is totally unrelated. Some very confusing, I know, but that's how it was. Okay, so then for a long time, JavaFX was part of the thing that you ship when you downloaded Java, but more recently it's not. So you have to install it separately. You've done all that in the lab. Swing was an earlier thing that was similar to JavaFX. And you all did Hello World or Hello Tutor in Lab 1. Hopefully you can remember all that. Well, you don't have to understand what was going on there, but you can remember doing it, I hope. And you saw the little screen come up and you had to change that line of code with your tutor's name. The reason why we did that in Lab 1 is sometimes setting it up can be annoying and difficult because of those changes. And we wanted to make sure you got all that working while there were tutors around to help you set stuff up. But we weren't trying to teach you anything about how JavaFX works. That's what we're doing now. Okay, so to make a JavaFX application, you need to extend a very specific class, which is called javafx.application.application. Okay, and then when you do that, you've got to override the start method. So you'll be prompted to do that by IntelliJ. And there are a couple of concepts you need to understand. First of all is the stage. The metaphor here is apparently theater, right? Or something like that, all right? So think of a stage. So the stage is where stuff gets put. A scene is lives on a stage, and you can see in that picture over there, you've got a stage there, and a stage actually corresponds to an operating system window, meaning that if you're in macOS, it will have a little thing at the top with the little buttons on the top left corner. If you're in Windows, it will have the Windows decoration on it, and so forth. And so if you set, for example, the title of the stage, it'll actually appear in your operating system at the top. So the actual appearance of the outside of the stage is a function of which operating system you happen to be running on. The whole point of JavaFX is that when you write a JavaFX application, it'll work on any operating system that supports JavaFX at least, okay? Anyway, the stage is the concept of a window in an operating system. The scene is a container of a graph of things, okay? And the graph is made up of nodes. Now, some of you have used applications like Adobe Illustrator maybe, or PowerPoint, and you know that you can have things like rectangles and text and so forth and move them around, and you can group them, and you can have groups of groups and so forth and so on. That's the same sort of concept here. So you can have a hierarchy, you can have a little thing here which is a piece of text, you can have another thing over here which is a rectangle, and you can make them together to be something else, and then you can put those two things together with something else. Okay, so you can create a structured thing, and you can do things like make that whole subcomponent display or not display, a bit like layers in some in something like Illustrator or some other applications like that. You can make a layer hide or appear. Same sort of thing here. You can make a group disappear or hide altogether, all the things inside that group. So what does a pane do? A pane, so a node is a leaf on this thing. So we have things like rectangles and text and so forth. And of course, I'm going to illustrate this with an example soon. And a pane is a way of organizing nodes within the graph. I'll make that obvious later in our example. But there are ways of basically, for example, centering things on a window, just as an example. And you can use these things here. A pane is a device given to you by JavaFX that allows things to be arranged in a nice organized way, like all the things evenly spaced out and so forth. Okay, so it's a useful concept. So the scene graph in JavaFX is a tree of nodes, as I said earlier, just like that concept in something like Illustrator, where we have a structured tree. And you can see over there on the right, you've got this notion. You've got two leaves on the left there, the circle and on the left of that graph on the right there. So the circle and a rectangle, they're leaf nodes. They're actually nodes. So one will literally be a circle. The other one will literally be a rectangle. Then you've got one here, which is a compound one. So it's a grouping of other ones, and it's got a text there and a thing here, which is an image view. An image view is, for example, like if you want to put a JPEG or a GIF or something like that in there. That's what this is called, an image view in JavaFX. Oh, and incidentally, let me remind you that we deliberately tried to give you a reasonably fancy JavaFX thing for assignment 1, so that you could look at assignment 1 and get ideas on how you might build things in practice. Okay, you can set node properties in JavaFX programmatically by saying, you can set the font and you can set the fill color, or you can use CSS. Okay, like style sheets, like we do with web pages. So you can do that sort of thing as well. Now with that, I'm going to go to the mini quiz. Where are we? There we go. The mini quiz should now be available. And with that, we'll go to try and do a nice little example, a very simple example of a JavaFX application. Here we go. And we'll create a package here, new Java package. X01, and then inside that package we'll create a new Java class, and we'll call it JFX Square. Right, in this very simple tiny class that I'm building here, we're just going to literally draw a square. That's all we're going to do here, okay? And we're going to start off by doing, I told you before, one of the most important things with JavaFX is you must, to implement a JavaFX application, you've got to you've got to extend the JavaFX application type. So we type extends like that, and then we say application. Now, if I let IntelliJ do the autocomplete, you'll see it's got a few there. Make sure you get the right one. You can see at the top there it says javafx.application. That's the one we want. So we go like that. Okay, now it's created the class thing there, and it says it extends application. It's done the import for JavaFX, and it's got a red light bulb here. What's the red light bulb about? Let's have a look. And it says, do you want to implement the methods that are needed? And remember, when I was showing you the slides a few moments ago, I said we need to implement a specific method, and that's the start method. And if we just, IntelliJ will help us, we just go like that, and there it is. So now we have the start method, and it passes us the stage, which remember is like the window. Interestingly enough, the size of the stage is carefully handled by JavaFX to contain whatever your scene is. So by setting the size of the scene, we implicitly shape the size of the window. All right, so first of all, let's give our stage a title. Dot set title. There it is, set title, like that. And we'll call it, what is it, JavaFX square. Like that. And then I think, let's just try this. The most important thing we need to do is this, stage.show. Unless we do show, we'll get nothing. Let's see what happens here, and let me see if I'm forgetting something else. The other thing you have to do is you have to set this up in, it's annoying to set this up, but I'm setting it up right here, JavaFX square, there it is. And for those wondering, I'm just waiting for it. It's just compiling down here. And what has it done? It's just, it's opened up a new thing. It's just this weird little window here that just says JavaFX square. That's all there is to it. Okay, hopefully you can see that. Get rid of that and go back to IntelliJ. All right, so it made us a window with nothing else except the title of it was JavaFX square. Great. Okay, if we didn't have this show, nothing would happen. Okay, we run this, nothing happens. We must show it to be able to see the window. Okay, so you've got to show the stage. If you don't show the stage, you get this, which is nothing. Okay, so there's no window here. Okay, so now let's go back to here and we'll quit this. It's still running, but it's not showing any windows. So that's particularly useless. All right, we'll go back to here. Now let's try and draw our square. Now the first thing we're going to do is make a scene. Actually, we're going to make a group first. And we call it the root group. So this is the, now go down here and you see here, we've got to make sure we get the right one. And whatever you do, make sure you don't get the swing stuff. Make sure you get JavaFX. Okay, there it is. It can be confusing to choose the right thing. IntelliJ will generally give you a good one. Just check, okay? Sometimes people get into troubles with their assignments or with their homework or whatever, and they haven't got the right imports here. They're using something else like swing, okay? So just always check that. So we've made ourselves a group, and that's going to hold things in it. It's like a container, okay? And what we're going to do first is going to create a scene. And the scene is going to be the thing that will go on the stage, and the group will sit on the scene. Okay, there it is. Scene equals new scene, and it will have as its group the root, which we just created there, and we'll make it 300 by 300 pixels. Okay, 300 by 300 pixels. And then finally we'll say stage.setScene, stage, remember the stage is the window, .setScene, scene. Okay, and I think with that, we can now run this again, and we'll now should have a 300 by 300 window. There it is. So now we have a window which is 300 by 300 pixels, but it's still not showing anything, okay, because we haven't added anything to it. Now we want to add a square to it, and the way we do that is by making a rectangle with the same sizes of the two sides, okay? So there's no square in JavaFX, but there is a rectangle, so we just make a rectangle. Okay, so we'll say rectangle, rectangle, there it is down there, R equals new rectangle, like that, and we'll make it 100 by 100, and we'll put it at an offset of 100 by 100. So if we do that, then it will have 100 of, be inset by 100, which should result in a rectangle with 100 around each side. So you've got 100 there, then 100 there, and then 100 there, okay? So let's do this. So that's the X and Y sizes and the offset. And then what we can do is we can set whatever color we want inside that rectangle. So it's like a paint, okay? So we'll just say a color, there we are, dot red. There it is. Okay, so now what we should do is we should find ourselves a window with a red square inside of it. But we don't. Why not? What have I done wrong? Well, what I've done wrong is I've forgotten to add, this is a classic mistake, so you're probably going to make the same mistake yourselves. So I'm glad I made that mistake. I forgot to add this rectangle to the scene. If I don't add it to the scene, to our group, to this group, the group here is empty. This is an empty group. We just created it. We've put that in the scene, and then we're then we've made that scene, what goes on the stage, and then we're showing the stage. This rectangle is not connected to it at all at this point. So what we have to do here is we say root dot get children, so we get all the children of the root, and then we say dot add the rectangle. Okay, so that will add the rectangle to this group, and then we press, and I can see I'm slightly over time. If you need to leave, please don't feel bad about leaving. I realize I'm over time. I'm going to forge ahead. There's our window with 100 there, 100 there, and 100 there, and it's square. Okay, so that's our first JavaFX application. We're going to make, the next thing we're going to do here is we're going to do a hello world thing, and I'm just going to show you how you do text. So that was a square. So now I'm just going to do hello world, and in fact I'm just going to cut and paste just to save time here. Hello world. Oh, one thing I didn't show you, which is actually important because it may cause confusion for you, is that we've set up these things up here for you in your assignment. We've set up these things for you. So you've got the hello world and square and the corresponding things for your assignments. But I didn't actually show you how to do it explicitly. You actually have to do some strange stuff, unfortunately. You didn't used to have to do that, but in more recent versions of Java, you've got to add this here. You've got to modify options, add VM options, and add this stuff here. And that needs to be done before it will run. Okay, I've brushed over that here. We can tell you more offline. You shouldn't need to do that. But if you build something from scratch, like I just did in the lecture, you will have to do that yourself. Okay. Now let's go to hello world. What we're going to do here is we're going to change this to say hello world. That should change the title at the top of the window, like that. And then, we can just change it. We can change it to whatever we want. Okay. And then what we're going to do now is instead of the rectangle, we're going to add some text. Okay. So let's just do that. So we'll say text hi equals. Whoops. Oh my goodness. Keyboard's unhappy. Oh my goodness. Text hi. Okay. Text hi equals new text, and then we'll write hello world. Like that. And now it's asking us which text do we want, and let's have a look here. And we press the keys as they say. Hang on. No, wrong one. Wait. What we need to do is we have to make sure we get the JavaFX one. So come on, IntelliJ. Unfortunately, it's behaving very slowly for me right now. Just making this a little bit, I'm waiting for it. Come on, JavaFX. Come on, IntelliJ. More actions. Here we go. There we go. We need to import which class? There we go. There's the one that we want. We want to import JavaFX scene.txt. And now we're in business. So sorry, that took a moment. Okay, now what we can do is we can do stuff with this. Now, before we go any further, what we have to do is we have to add that. So we don't have a rectangle anymore, we've got text. So we add hi instead. Like that. Now, what happens if we run this? Let's just try and run it. We go, hello world, run. And there it is. But where's the text? The text is missing. Okay, we've got a little bit of a problem here. The text is missing. Why is the text missing? Well, it's actually not missing. It's actually hidden. Let's just do it. We'll do a little bit more here. We can set font. We can set the font. That's something nice we can do. So we can say font dot font, and then we can specify a particular font. Like you can use whichever font you want, like a tar from any font that's on your computer, right? So. And we'll just use a fairly standard one, which is on most computers there. Font weight, you can set the weight, font weight dot black. So that's like a heavy font, you know, it's like a boldface or whatever. And then the size, that's 40, okay? So we didn't specify any of this, so just use some weird default. Now here, let's go here and make sure we import the right one. There it is. Great, it's imported the right one. If we can expand this, we can see we don't need the color in the rectangle anymore. But there you go, you can see these things. Now what we're going to do is we've made it black. We can still set the high dot set fill. And we can make it red again if you want, or whatever, it doesn't really matter. We can make it royal blue if you like. Okay, royal blue. And then we should get something, right? Let's have a look. I'm nearly finished, folks, and I'll wrap the lecture up in just a few moments. Let's have a look at what we get. Still nothing. Now, if you've got really sharp eyes, you'll notice right there, right there, right there, and right there is a tiny bit of blue. And if you've got a good imagination, maybe you can guess what's going on here. What's happening is our writing is being put right at the top of the window, which is not where we want it, okay? And so we haven't specified where this is going to go, and it's just dumping it at the top of the window, which actually puts it off the window, and we're just seeing the tiny bit of the bottom of some of those letters. That's all if you've got sharp eyes. So what we're going to do, instead of using this group here, what we're going to do is we're going to use a stack pane, which I mentioned in the slides earlier. Stack pane, which is and the garbage truck behind me, the joys of lecturing from home. All right, so we're making a stack pane like that, which is just like a group, but it has this nice property that will organize things for you in a kind of natural way. Now let's see what happens. Let's see if we run the same thing again now. There we are. So what we see is hello world, written in a particular font, Tahoma, written in a particular weight, it's black, and it's centered automatically by the stack pane. Okay, two very small last things before we go. We're going to just some little things we can do here very easily is high dot set opacity. So we can make the opacity of the font different. Set opacity, right, of the text, right? Opacity of the text. We can make it, I don't know, let's just do this like that, run that. So now what we should see is a transparent text, okay? And if you had another thing in there, maybe like a square underneath it, you could see partway through. So now you can see it's transparent with a little bit of, so you're seeing the white coming through the blue. The last thing we're going to do is make the stage transparent. Stage, what's a stage? The stage is the window, remember? Stage.set opacity. So we can actually make that transparent as well. We'll make that 0.5 and run this. And now what we should find is, oops, I left that window going. I had to stop it, now start it again. Now you can see the entire window. See how you can see the word mini quiz there? The entire window now is transparent. Okay? And with that, we're finishing up. I'm going to do X02 on Monday, but that's your basic intro to JavaFX. And now I'll skip over these slides here and move to our bio. Our bio today is Jeanette Wing. Jeanette Wing is a professor at Columbia University. She's a very influential computer scientist today. She doesn't have a Turing Award, but maybe she will. She'll get one. Interestingly enough, she worked with another one of our most eminent women in computer science who did get a Turing Award, and that's Barbara Liskov. They worked together when Jeanette was a student. She has been one of the directors of the National Science Foundation, or assistant director, and head of one of the largest computer science departments in the world. And one of the things she did is, she's famous for formal methods, object-oriented programming, and she coined the term computational thinking. If you've ever heard people talk about computational thinking, that's work that Jeanette did. Anyway, Jeanette's another contemporary example of an absolutely outstanding person in computer science. And with that, I'll finish up. Don't forget, if you're doing it tough due to COVID, and I know many of you are, you can write a special consideration form to the university explaining what particular circumstances you had, and so please do make use of that. If you feel like you can't submit any piece of assessment, you can always do that. All right, and with that, I'll finish up, and thank you to Leo for voicing your one or two really good questions, and and